we have radical word problems. We have, in the past, we've only dealt with radicals themselves, how to simplify them, how to add them, how to subtract them, how to whatever, divide them, how to solve problems. But now we're going to look at actual word problems. But before we do that, we've got to look at a particular formula, which is called the Pythagorean theorem. It's a very, very famous, it's a very famous formula. And it says, this is the formula, a squared plus b squared equals c squared. And this is actually how I created a right triangle. I used this formula when I was building a cabin for a friend at his house. I didn't have, it's kind of hard to get a perfect right triangle. So I, with a little teeny square, I think my square was a tiny little like this, it just didn't feel quite big enough. And so I used a process, and I'll explain that in a few minutes. But so what you have to understand is, for the Pythagorean theorem to work, you have to have a right triangle, okay? And a right triangle means one of the angles is 90 degrees, right? That's 90 degrees. And so these are called legs, right? L, E, G, and this is a leg, L, E, G. The legs come off the 90-degree angle, okay? And you'll notice the longest side is called, on a triangle, what's it called? What? Oh.
The arm?
Oh, no. Hypotenuse, thank you. Hypotenuse. Hypotenuse. All right? The longest side is always called the hypotenuse. And when you look at this formula, the C is always the hypotenuse. Always. Okay? So that means it doesn't really matter which one I make A and B. I could have made this A and this B, or this A and this B. But this long side always has to be C. Okay? So if I asked you to find the distance, the length of the hypotenuse, right? Okay? I could use this formula. So let's say I said, if, here's my first problem. If A equals 3 and B equals 4, find C. So finding C means I'm looking for the length of the hypotenuse, right? So, and I'm talking, let's say inches, so that we're dealing with real things here. Inches. And I want to find C now. So what would I do? I would say, I would rewrite my formula, a squared plus b squared equals c squared. And then with that, I would plug what I know in. I have A is 3 inches, right? That doesn't look like inches. Inches, right? A is 3 inches, so I'll write 3 squared plus B is 4 inches, so I'll write 4 squared equals C squared. Okay? All right, so make sure you're writing these things down, Henry, so you've got this, so you understand them. And then, so 3 squared is 9, plus 16 is equal to C squared. So 9 plus 16, I think that's 25, equals C squared. I'm going to put my C squared on the left side. So C squared is the same as 25. All right, so how would I find C?
Add 9 and 16, and then square that.
Say what again?
Add 9 and 16.
All right, which is I did. I got, exactly. So I've got, so I've got C squared is equal to 25. I want to find C.
Oh, divide that by 2, right? Would you cut that in half?
How can I, yeah, what's the opposite of C squared? I mean, excuse me, what's the opposite of a square? A square root, right? So if I want to take a c squared and turn it into c, I would take the square root, right? But whatever I do to one side, I have to do the other. So I have to take the square root of 25. So now c is equal to 5. 5 inches. So we've figured out that my hypotenuse is 5 inches when my legs are 2 inches and 3 inches and 4 inches. Okay, does that make sense? Okay, it's pretty straightforward. Now, this is exactly how I created my right triangle when I was building that cabin. Because I basically said, okay, I had the boards nailed together, right? But I didn't know whether to move it further out or further in, you know what I'm saying? To get the perfect 90 degree. And so what I did, I had my two boards, right? Like this and like this, right? And then I measured, what? I'm sorry?
Should I write this down?
No, you don't have to. I'm just showing you what I did. But I said, oh, well, I know that if a 3 foot by 4 feet would give me 5 feet, right? For a hypotenuse. So I measured 3 feet. So 1, 2, 3, and that was 3 feet, right? And then, how far did it go? 1, 2, 3, 4, and that was 4 feet. And then I knew that if I took a piece of line that was exactly 5 feet long, it would have to exactly touch that point. Does that make sense? And if it did, this would be a perfect right triangle. That's what I did. And it was a perfect right triangle. It was a masterpiece. It was a tiny cabin, but it was fun. But that's an example. I used that instead of trying to use this tiny little square that I had, and it was much more accurate. Does that make sense?
What do you use it? Like, what do you use that piece for?
Oh, it was a cabin. It was for the foundation, right? And then it's like, right? And I built it up from there, right? And so there's a lot of other math I used on that too, but that was that one. So this Pythagorean theorem is really critical. Whoops, I just erased it. Is really critical to understand. Now I'm going to just write the formula again, and then I'm going to write a word problem. Or I'm going to create a word problem on the spot. So here we go. So here's our word problem. Weston wait a minute. Hang on, I better say so. Weston and Adam left at the same time and place. But Adam hiked north 10 miles, and Weston hiked, say, east 4 miles. Okay. Let's see, what could happen that makes them so suddenly Adam gets hungry and has no food. He calls Weston.
Said he forgot the book.
And Weston decides
Write a novel, Gary.
to hang glide. How do you spell hang glide? Hang glide over to Adam to save his life.
Sounds like a story more than
Oh yeah, right. I forgot. We're in a word problem. This is a math class, right? Okay, hang glide. Okay, so so
Where was that from?
how far did he fly? Right?
We're all doing hand gliding here? That's so cool.
Great. So here we go. So let's look at our problem. Weston and Adam left at the same place and the same time and place, but Adam hiked north. Okay, let's just draw our picture first. We've got they both left from here, right? Am I on here? Yeah, looks like I'm just barely. Okay, they both left from here. This is Adam, right? Adam. And this is Adam. Adam. And then this is Weston. And Adam went 10 miles north, right? So 10 miles. Right? And Weston, this is Weston. Weston. And he went 4 miles, right? Am I right? Is that what he said? 4 miles. I hope that can be seen. Okay. So, and then suddenly Weston flies right there. So this is my right angle, right? Because due north and east, that's my right angle. So my A's and my B's are right here. Doesn't matter which one's A and which one's B. And I'm wanting to know how far Weston had to fly to save Adam's life with a granola bar, right? Cliff Bar, excuse me. Cliff Bar, excuse me. I apologize. Okay, so so how do I do it? What do I do? Okay, Gillian.
So you do. So I'm just gonna use Adam as A. So A.
Okay. So we'll say this is A, and this is B.
Yeah. So
Okay.
10 squared.
So wait a minute. I'm going to write my formula. Okay, go ahead.
10 squared
10 squared.
plus 4 squared.
Okay.
C squared.
Okay.
It would be 100.
100
plus 16
plus 16.
equals C squared. And then would you.
116 equals C squared. Now what?
would
I'm going to
you
put my C
square-
squared on the left.
Square it. Both
Yep.
sides?
Square both sides.
Never really know what the square root is.
So what you do is you take out your handy dandy calculator, right?
That you happen to have on the
Which
headline.
you happen to have. Weston's actually, he's got time up in the air, right? So he gets out his calculator and he says, let me think. He went 10 miles, he went 4 miles. So that's 116. So he does 116 and then he hits the square root sign and presto, it is 10.77 miles. Is that longer? It's got to be the longest side. Would that be the longest side? Yeah, that makes sense, right? 10 miles, 4 miles, 10.77 miles, almost 11 miles. All right?
Whoa,
So it makes sense, right?
that's
Okay, where's my other marker? Erase.
Gary,
Okay, can I erase this?
Gillian's potato was Weston.
What?
Gillian's potato was Weston.
Penguin and the potato.
Oh, I could have, yeah, the potato could have rescued.
The penguin.
Yeah.
Adam, if you would prefer, you could be rescued by a potato.
Yes.
Weston's no longer here.
I was watching this video like on YouTube.
Okay,
Gary, you should write
periodically.
a novel.
905. Periodically, you'll get something like this. Yeah, I think I'll just give it to you because I think it's fairly straightforward. There will be some where you will actually find the area, okay, and Yeah, I think I'm going to give it to you. I think you guys can do it. So I'm gonna